Alright, so this is going to be one of the probably many to come videos for our pre-algebra class. Obviously you guys can see that this is a different type of text than the purple pre-algebra books that we have in our room. In your e-backpack folders there's actually a textbook there for you. I have put the first chapter of the material for the textbook in there. It's going to have a little bit different order. We'll have different quizzes and different homework assignments, so just be prepared to bring headphones to class and go through these videos at your own pace. That way you can watch them a couple times if you need to, ask questions on them if you need to, and make sure that you completely understand the lesson that you're on and answer all the questions correctly before you move on to the next one. These first couple are going to be pretty simple. It will get into some things that are a little more challenging for you guys. I know that this curriculum is a little bit different. So this first lesson for Chapter 1 is whole number operations. And the very first thing that they talk about with whole number operations, again, whole numbers are going to be all of your positive counting numbers. And I'll talk about the different sets of numbers again at some point in the chapter. But as of right now, we're just going to operate with the whole numbers. It's the positive counting numbers. So when we do this, we won't have to worry about fractions or decimals or anything like that right away, and we will work our way into those things. First thing we have is a table with some operations. You can see the operations down this left-hand column. We have addition, subtraction, multiplication, and division. Then we have some translation words in the middle. These by no means are the only ones. We have the sum, the difference, the product, the quotient. You guys might also recognize plus, minus, less than, more than. For quotient, it could say divided by. For product, it could say multiplied by. So keep those things in mind. And then on the far side, algebraically, there are some terms here: a plus b, a minus b, a times b with an x, a times b with a dot. We also should recognize another a times b, so I'm going to draw a little arrow down here. So for another multiplication one, we could see a times b written like this as well. Sometimes when there's variables involved, you might just see 3x like this. That's multiplication. Likewise with division, you see some here, so I'll do division in red. You have a divided b, a over b, b divided by a. But again, understand that if I have something like this, if I have a variable x over 2, that's x divided by 2. That's not a fraction problem. So understand that that's how those two things are hooked, and that's pretty much the basics of what we're doing first here in this chapter. So moving on, you'll notice that this textbook is still kind of challenging. It has you guys read some problems. If you read through them a couple times and understand what's going on, you should have no problem understanding how to answer a problem. You'll see here that on example A, if you go to your textbook material, the answer is already written right here, but we're actually going to do A together. For B, I didn't scratch out all the work, so you guys can all talk through the work and you guys can kind of follow the logic there. But what we need to do before we do anything is we have to look over this bar graph. So it says it's a bar graph of an art festival attendance, and there's 3 days of attendance. So art festival attendance, there's 3 days, 1, 2, 3, right across the bottom. The number of people, they have 500, 1,000, 1,500, 20, or 2,000, 25, 3,000, 35, 4,000, and so on. And then you can see here this bar graph, you don't have to guess where the numbers are. They give us 2570, 3145, and 3876. It says, what is the total attendance of the art festival? So obviously, if I want to know the total attendance of all 3 days, what I want to do is add those all three together. So what I'm going to do is go ahead and zoom in on this problem here real quick, and then I'll zoom back out when we're done. When we're doing whole number addition, this shouldn't be too hard. We're just going to count. We start on the right-hand side of our problem, and we work our way left. So we're going to start over here, and we're going to work our way to the left. So we have 0 plus 5 plus 6. 0 plus 5 is 5, plus 6 is 11. I carry a 1. 7 plus 4 is 11, plus the 1 that's up top is 12, plus another 7 is 19. So I have a 9, I carry the 1. 1 plus 5 is 6, plus 1 is 7, plus 8 is 15. I carry the 1. Then 1 plus 2 is 3, plus another 3 is 6, plus another 3 is 9. So hopefully we got the same answer that we did as the book there, 95, 91, and we sure did. So that's kind of how we follow that problem. Again, we could see the answer there before I worked that problem out, and that's how you do that. With subtracting, it's a little bit different. It says, what is the increase in attendance from day 1 to day 2? Well, we want to figure out what the increase is, so what we need to do is take the bigger number minus the smaller number to find that. And you can see that that's what they did. They took 3,145 minus 2,570. Notice here, again, I'm not going to erase these things, so you're just going to have to kind of listen, and I'll kind of instruct you with the dot. 5 minus 0 we can do. 5 minus 0 is 5. But then students sometimes confuse 4 minus 7, and they'll put something like 3 here. Well, you can't take 4 minus 7, so what we have to do is go borrow from the 1, and now that 1 becomes a 0. You'll see that 0 is already crossed out, and we'll get to that here in a second. When we borrow and that 1 becomes a 0, that makes this 4 a 14. 14 minus 7 is 7. Then with our next digit, what was once a 1 is now a 0, so we have 0 minus 5. Obviously, we're going to have to borrow. We cross the 3 out, and we make that 0 now a 10. Now we have 10 minus 5 is 5, and then we can go to our next digit. 2 minus 2 is 0, so we don't need to put a 0 there. We get our answer, 575, and our answer is talking about people, so you'll see here, pardon the shakiness, you'll see here that the answer is the increase in attendance from day 1 to day 2 is 575. Okay, multiplying whole numbers is very similar. A school lunch contains 12 chicken nuggets. 95 students buy the lunch. What is the total number of chicken nuggets served? So if each student gets 12 nuggets and there are 95 students, you multiply it. Notice here in the book, I'm going to talk about how they do the work so you can see it. They start by multiplying the 5 by 12. When they do that, they say 5 times 2 is 0. They carry the 1. 5 times 1 is 5, plus that 1 that they carried is 6. The only thing that the book didn't do here that I'm going to go ahead and add here is they didn't show the 1 that was carried. Okay, so I wrote a blue 1 there so you can see it. Then for the red, another thing that the book didn't do here that I'll like you guys to do is when you go over to the 10 spot, go ahead and add that 0 there. That way you know that nothing should go there. Then they take 9 times 2. Again, 9 times 2 is 18, so I'm going to put that 1 up here in the problem. And then 9 times 1 is 9, but we have to add the red 1 that's up top, and we get 10. Then you guys will just add those two things together. So 0 plus 0 is 0. 6 plus 8 is 14. We would carry the 1. 1 plus 0 is 1. 1 is the only thing that's left out in front, so we get our total 1,140 chicken nuggets. Okay, so this is kind of like your guys' guided practice. So what I'd like you to do before you go ahead and watch this video is I want you to pause the video right now, and on a sheet of scratch paper, go ahead and work these out. Also, don't forget that before you pause the video, don't use a calculator on these. Go ahead and show your work. I'm just going to write the answers in, but if you got a different answer than I got in the video, don't hesitate to raise your hand and have me show you what you did wrong or have me look over your work. For this first one, we should get 2,427 for an answer. The second one, we have 912 minus 799, and we should get 113. And then the last one, what we should get, 42 times 118 is 4,956. So again, if you didn't get that answer, have me come check your work over, raise your hand, and after you figure out what you've done wrong, we'll go ahead and move on to the next example. Again, with example 3, you guys, I'm kind of helping you by talking through these examples. I want to read this problem to you and have you guys hear what the problem says. And then after you hear the problem read, what I'd hope that you can do is kind of set this problem up on your own. That way we can kind of challenge ourselves to do this. You'll see that the work is all already done, so it doesn't do us any good to just look at the answer. We're going to talk through that as well. So let's go ahead and look at this. You make 24 equal payments for a go-kart. You pay a total of $840. How much is each payment? Well, if my total cost is $840 and I'm going to split it up into 24 payments, I'm going to take 840 and I'm going to divide it by 24. So we should know that 840 divided by 24, if I want to write it as a fraction, I could put 840 over 24, but if I want to divide it out and find my answer, I want to go ahead and use long division. So a lot of us don't like to do that. We're going to practice and get better at it. I really like the way that the textbook does this. It shows you how to break this example down. So we have our first question right here. Use long division to find the quotient. So I'm looking at this right here. Decide where to write the first digit of the quotient. So where these little question marks are, can I write the digit there over the hundreds place or here over the tens place? Well, if I look, 24 does not go into 8. So obviously I can't put my first digit in the hundreds place. That just means that 24 will not go into 840 over 100 times. But when we look at it better, we can say 24 and 84. Well, 24 obviously will fit into 84 several times or a few times. So that's going to go, our first digit that we have is going to go into the tens place. Once we do this, what I tell students to do if they're unsure is to look at maybe a multiplication table or something to see how many times it will go in. And so 84 will fit in 24 will fit into 84 3 times. So then what we do is we take this 3, and if you're not sure, just say 24 times 2, 24 times 3, 24 times 4. Once you hit 4 up here, you should see that the number here is too big. So 24 times 3 will give us 72. Then what we do is we subtract 84 minus 72, and we get our answer 12. Well, then what we do, regardless of what this digit is we take this digit that's in the ones place and we drop it down. So it happens to be a 0 this time. It could be anything, and we're going to drop it down. Then our next step, you'll see that they did that same motion right here in the book. They dropped it down, and we figured out how many times 24 went into 120 now. We already know that it won't fit into 12 because we tried to find the biggest possible number for 84. If it would fit into this number again, that means your number that's in the numerator is too small, or your number that's on top is too small. So now that I have 120, I'm going to say 5 times 24 is equal to 120, and I see that I have a nice even number when I subtract here, and I get 0. So I actually don't have a remainder here, and we'll talk about remainders here in just a minute. So we end up with $35 24 times, and to check our work over here, I really like the way that the book checks their work also. We can see that we get the right answer. Okay, so this is another opportunity for us to practice on our own. Again, try your best not to use a calculator unless it's something like, I don't know how many times 58 will fit into 98. And you would say like 58 times 1 is whatever, 58 times 2 is whatever, or things like that. But try your best not to use a calculator and try these real quick. So go ahead and pause it and show me long division, and then we'll talk about these real fast. For right now, let's just try 4, 5, and 6. If you really want to challenge yourself, go ahead and try 7, but let's pause right now. Okay, now that you've had an opportunity to try some of these, let's go ahead and go over the answers. Again, if you don't get the same answer that I do, go ahead and raise your hand and we'll see if we can't see where we went wrong. Number 4, we should get 26. Number 5, we should get 17. Number 6, we have 840 divided by 105, and we should get 8. And if you really wanted to challenge yourself, you should have gotten, for number 7, I believe it's 31. Okay, this last one, odds are if I give you guys a story problem in your homework, I'll probably help and talk to you about it beforehand. So I do like to talk about the real-life application of what's going on in here. In the previous slide, there was a problem at the end, or not a problem at the end, but a statement at the end that said that if you take the dividend and you divide by the divisor, you will sometimes end up with what's called a remainder, and all we need to do for that remainder is put it over our divisor, and I'll kind of talk about that as I go through this last example, and then we'll talk about what we're supposed to do for homework. So example 4 says a 301-foot high swing at an amusement park can take 64 people on each ride. A total of 8,983 people ride the swing today. All the rides are full except for the last ride. How many rides are given and how many people are on the last ride? And then it even says here, to find the number of rides given, you need to find the number of groups of 64 people, because that's all that can fit on the ride, fit into 8,983 people. So what we need to do is we obviously need to take our 8,000 and put it inside the box, and we put our 64 and we put it outside the box, just like the problem has here. Again, the work is all here, but we can think about this one step at a time. Does 64 fit into 8? Well, obviously not. Does it fit into 89? Yes, it fits into 89 one time. So we take 1 times 64 and we get 64. We take 89 minus 64 and we would get 25. That 8 wouldn't be there. But what we do is we drop our 8 down and we get 258. Again, if you're not quite sure how many times 64 would fit into 258, is you could start multiplying numbers. If I take 64 times 3, it's going to be too small. If I take 64 times 4, I get 256. And obviously it's not going to fit in there another time because the difference is just 2. So if I take 258 minus 256, I get 2. I drop my 3 down and I get 23. We can see pretty easily that 64 does not fit into 23. We don't put a decimal point here and add a bunch of zeros. We're just going to put it as a remainder over 64 for this particular problem. Sometimes when a teacher wants your answer as a decimal, they will tell you to put a decimal place. So you'll put a decimal place right here and up here and just keep going as a decimal. But because we're talking about people, we don't want to put them as a decimal. We want to say that those are the remaining people that did not fit as part of one of the full rides. They're the 23 that rode at the end by themselves. So what they're talking about here is how many full times did that ride go at the amusement park? Well, it went 140 full times, and then on the 141st time, 23 people went on the ride. So technically, there were 140 rides given at that amusement park on that particular ride. Okay, so let's talk about your homework for just a second. I have put the book material for this particular book in eBackpack for you guys. Again, we've been doing those little dog worksheets, and we've been doing these solving expressions. So we'll talk about some of that stuff later on if we can get you guys kind of tracked into where we are with the other pre-algebra book. But if you're working out of what we're going to call the Green Pre-Algebra book, we're going to find our book in the book material. If I click on book material, you'll find the textbook pages, and they'll be in there chapter by chapter. So for right now, chapter 1 is all in there. And what you'll do is you'll go to the lesson and look at the examples. You don't really need to look those over again because I showed you all of them in this video. But after you get through the example pages, you'll come to a page that looks like this. Once you get to this page, this is your exercises. So what I'll probably do for you guys is give you some exercises from this particular page. I can't scroll up to see. I don't think I can I? No, okay. So I can't scroll up all the way to see what page this is. It's just the 1.1 exercises page. And what I'll have you guys do for this particular lesson is go ahead and do the problems that are even all the way through. Okay, so all the way through to the very end, and then if we run into a couple that are maybe a little too tough, we'll talk about it. But as of right now, let's just work on the evens from the 1.1 exercises, and we'll pick up with lesson 1.2 when we're ready for it.